table. It's from section 3.1 in the chemistry text. Well, we kind of start out with John Newlands in 1865, and what he said was that we can organize the first 16 elements by atomic masses into two rows, going lightest to heaviest. We could have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And what he realized or noticed was that there were similar properties that he called the law of octaves, octaves for 8. So he looked at the lithium through the fluorine and noticed that there were similarities, and he related this quite a bit to music. Dmitri Mendeleev in 1870 organized the then known 63 elements by, again, atomic mass, so that's the same as Newlands. And he also grouped similar properties. This was slightly different from Newlands. The real key thing that made Dmitri Mendeleev just a pioneer was that he left open spaces in his periodic table for elements that he expected would be there based off of the properties. He made predictions about these properties and about other things about the element. And it was based on all of those properties of the elements around those open spaces. And as we notice, quite a few of these were spot on. It does look quite a bit different from our current periodic table, not only because of the fact that he only had 63 that he was looking at, but also because his organization was based on that atomic mass, and we know that a clearer way of organizing them is based on atomic number, the number of protons in the nucleus. In 1910, Moseley decided to start hitting some elements with X-rays, and he derived a relationship between X-ray frequency and the number of protons. So he really was the first one to start looking at what we know now as the atomic number. So he organized the elements according to the increasing atomic number, and this decreased any of the troubles that Mendeleev's table had. There were some troubles by organizing by atomic mass. And this is how our modern periodic table is organized. And the picture at the bottom is a periodic table from 1930. So notice we've gotten slightly more clearly organized now. Some other ways that we can see the periodic table organized in this grouping and atomic number way is the extended periodic table. I have a copy of one of these in my classroom, and this is just actually, oops, sorry, my kitty cat is climbing on my computer right now. Okay. The extended periodic table is organized by atomic number, and it puts the F row in there where they actually fit. So if you look at the numbers on our regular periodic tables, you'll see a skip. And you'll also see a little star or something that shoots you down to the bottom to say, okay, this is where that F group is. Well, it really fits in there. They just don't often put it in that way because you can see it's just so very long. At the bottom, we also have a periodic table that I have another example of in the classroom if you want to see this. It's a 3D way of representing, and it's just grouping by atomic number and similar properties. It's just fun to have it in 3D. So some of the basics about the periodic table. We are organized in periods as we go across, and that's why we've got red at the top. So hydrogen and helium we can kind of group together. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon are the oranges there. We can group those in a period, and that's just going up atomic mass for each of the rows. So period is as we go across, and it gives the number of energy levels. And we can also group by groups, and those are the columns. They go up and down, and they give us the number of valence electrons, which we looked at quite a bit in Chapter 2.